So as you go through today's lesson, you will notice that you will need to pause the video to take notes. That's perfectly okay and actually expected, all right? So this is lesson 6.4, Properties of Special Parallelograms. And the main objective for today is to prove and apply properties of rectangles, rhombuses, and squares. So what I want to do, first of all, is look at the relationship between quadrilaterals. So we are going to create a quadrilateral flowchart. So I'm going to start off by just drawing a random quadrilateral, which is a four-sided polygon. Then from there, I'm going to add a couple rules. And what I'm going to say is that all sides of the quadrilateral have to be parallel. In that case, that is a parallelogram. So that is two pairs of parallel sides. I'm going to mark that here. So a parallelogram is a specific type of quadrilateral. Well, specific type of parallelogram is a rectangle. So a rectangle has two pairs of parallel sides, but it also has four right angles. So a rectangle is a parallelogram and is a quadrilateral. So now we're going to look at a specific type of rectangle, and that is a square. Now it has two pairs of parallel sides and four right angles, but it also has four congruent sides. So a square is a rectangle, and it is a parallelogram and a quadrilateral. Okay, so I have another shape that I want us to look at, and it is going to be a rhombus. And a rhombus is a parallelogram with four congruent sides. So I kind of think of it as like a tilted square. So here, a square is a rhombus, but a rhombus is a parallelogram and a quadrilateral. Okay, so let's add a few more quadrilaterals to our flowchart. We won't be talking about them today, but they're helpful to have as a reference. So I'm going to draw a trapezoid. A trapezoid has just one pair of parallel sides that I'm marking here. And then there is a specific type of trapezoid, and that is an isosceles trapezoid. So in addition to having one pair of parallel sides, it also has two sides that are congruent. And marking those two congruent sides here. Alright, so the last shape I want to add to our flowchart is a kite. And this shape, I like the name of it because it actually looks like a kite. So this one has two pairs of congruent consecutive sides. So consecutive meaning they are next to each other, and then they are congruent. So now we're going to take a closer look at the properties of rectangles. Focus on just that one shape. If a parallelogram is a rectangle, then its diagonals are congruent. So kind of showing a shorthand here, rectangle implies that diagonals are congruent. Let's draw a diagram of what this looks like. I've got my rectangle here. Then I'm going to label the vertices A, B, C, and D. Then draw one diagonal in blue and the other diagonal in green. So now I can say that AC is congruent to BD. And this is a really nice property to know. So if you ever have something that you want to know if it's a rectangle or not, to simply measure the two diagonals. If they're the same as each other, then you know you have a rectangle. It's a lot easier, quicker, and more efficient than trying to measure each of the four sides and then make sure that there's 90 degrees angles between all of them. Just measure the two diagonals and then you are done. Okay, so that was looking at the rectangle. Now we're going to take a closer look at the properties of a rhombus. We're going to focus on two properties of the rhombus. So if a parallelogram is a rhombus, then its diagonals are perpendicular. So if you have a rhombus, then diagonals are perpendicular. So draw a diagram of this. I'm going to draw my rhombus here. So all the sides are congruent. And then those two diagonals would be perpendicular to each other. The other property that we're going to look at is that each diagonal bisects a pair of opposite angles. So if you have a rhombus, then each diagonal bisects opposite angles. So I'm going to draw my diagonal here in blue and label these angles angle 1, 2, 3, and 4. Then I'm going to draw my other diagonal in red and label those angles 5, 6, 7, and 8. Now using this property, I can now say that I know that angle 1 is going to go into angle 2, angle 3 is going to angle 4, 5 to 6, and 7 to 8. But what's also interesting about this is that all the ones in blue are all equal to each other, and all the ones in red are all congruent to each other too. And we could prove that because we know that since these lines are parallel to each other, those ones are parallel, that we know that 3 is congruent to 2 because of alternate interior angles. And for instance, 6 would be congruent to 7 because of alternate interior angles. Now let's look at how we can apply the properties of rhombuses in a situation. So in this problem, we're first asked to find AB. Now we're told that this is a rhombus, so then we know that all the sides have to be congruent to each other. So we know that this side here, BC, where it's 4x plus 15, has to be equal to CD, or 7x plus 2. So we set those two expressions equal to each other. And now we're going to solve for x. So 13 equals 3x, and then divide by 3, which will give us a fraction, but that's okay. So we get 4 and a third is what x is equal to. So we want to know the length of AB. So let's plug 4 and a third back into one of these two expressions. I'm just choosing this one here, the 7x plus 2, but the other one would give you the same answer. So here we get 7 times 4 and a third plus 2, and that will end up giving us 32 and a third. So then the measure of AB is 32 and a third. Okay, so for the next one, we need to find the measure of ABC. Now there are different ways of doing this. So if you're doing it a different way, that's perfectly fine. But what I'm going to do, first of all, is try to find out what y is. Now I know this has to be 90 degrees in here because that's the property of a rhombus. And I get that y is equal to 7.5. Now I want to find the measure of this little angle up here, BCF. So I plug in 7.5 back into y. I'm going to find out what the measure of that angle is. So I know within this little triangle up here at top, BFC, that this angle here is 90 degrees. And now we know that this is 29 degrees. And now we can find the measure of this angle here because of the triangle sum theorem. And so since this is 90, we know that this one here has to be 90 minus 29 to get that angle. So CBE is equal to 90 minus 29. That gives us 61 degrees. Now that's just that little part. Now we want to know the whole thing. And since that bisects the angle, I can double that to get the whole thing there. So 2 times the measure of that little angle will give us the measure of ABC, and that will make that 122 degrees. So what I'd like you to do now is just take a moment, make sure your notes are really good on the properties of rectangles and rhombuses, and also that flowchart we did for how the quadrilaterals are related to each other. So there's an assignment for today, so make sure you check Classroom for that assignment.